This lesson video covers topic 2.4 annuity. This lesson video consists of several subtopics, including learning outcomes, introduction to annuity, future value of ordinary annuity certain, and present value of ordinary annuity certain. By the end of this topic, students should be able to 1. Explain the term ordinary annuity certain, 2. Derive the future value and the present value of ordinary annuity certain, 3. Find the future value and the present value of annuity, 4. Solve the annuity payment R, the number of payment N, and the interest rate I, 5. Identify the problems where the present value and the future value of annuity formula can be appropriately applied. Before we go further with the topic, let's discuss this example first. At the end of every 6 months for 2 years, 1,000 is invested in an account that offers 8% compounded semi-annually. Find the account amount at the end of 2 years. According to the question, K here is 0.08, T is 2 years, M is 2, which is referred to semi-annually. Hence, I is 0.08 over 2 and N is 4 interest period. Let me show you in figure. There are 4 times interest will be calculated in 2 years. 1,000 is invested at the end of each interest period. To find the account amount at the end of 2 years, we need to bring all of 1,000 to the end of 2 years. For example, bring this 1,000 to the end of year 2 and invest with 0.08 over 2. Bring this 1,000 to the end of year 2 and invest with 0.08 over 2 and N is 2. And bring this 1,000 to the end of year 2 and invest with 0.08 over 2 with N is 3. Therefore, amount at the end of 2 years is the summation of all these. Hence, the account amount at the end of 2 years is 4,246 ringgit 46 cents. For your information, this amount also can be calculated by using annuity formula. Now, let me introduce to you an annuity. Annuity concept enable people to plan for the future in terms of investments and savings. Financial consultants use annuity calculation to advise people on investment. A property agent uses annuity calculation to estimate the repayment of housing and car loans. For property purchase using a financial loan, regular annuity payment can be estimated using annuity concepts. Correct and effective use of annuity concept enable people to make good decisions. Annuity calculation can also help people plan for their retirement and investment. Annuity is a series of equal payments made at equal intervals of time. Examples of annuity are shop rentals, insurance policy premiums, annual dividends received, and installment payments. In each case, equal payments are deposited or paid periodically over time. Annuities can be classified into many classes, including annuity due, annuity certain, general annuity, perpetuity, and others. In this topic, we shall mainly discuss ordinary annuity certain, where payments are made at the end of the payment period and the interest and payment period are of the same interval. Note that, unless specified, money invested every period is understood to mean money invested at the end of every period. There are two formulas under ordinary annuity certain, namely future value of annuity and present value of annuity. Look at first on future value of annuity. Future value, or commonly known as accumulated value of an ordinary annuity certain, is the sum of all the future values of the predict payments. The derivation of the formula of future value of ordinary annuity certain is shown below. Predict payment is denoted as R. Interest rate per interest period is denoted as I%. Term of investment is denoted as N, which means an interest period. Future value of annuity at the end of an interest period is denoted as S. According to the definition, future value of annuity is the sum of all the future values of the periodic payments. The formula of S is simplified as on next slide. Here is the formula of future value of ordinary annuity certain once simplified. The formula is S is equal to R multiply in bracket 1 plus I power of N minus 1 over I, or also can be written as S equal to R multiply with S angle N at I, where S angle N at I is the future value of annuity of 1 per payment interval for N interval. Interest in future value of annuity can be calculated as I equal to future value of annuity S minus N interest period multiply periodic payment R. Let's solve this example by using annuity formula. As we all know, interest here is equal to 0.08 over 2, N is equal to 4, and R here is equal to 1000 ringgit. So from the formula of future value of annuity, S equal to R multiply 1 plus I power of N minus 1 over I. Substitute the value of R with 1000, the value of I with 0.08 over 2, and N with the value of 4. Hence, the answer is equal to 4,246 ringgit 46 cent, and this value is consistent with this value. To calculate the amount of interest, use formula of I equal to S minus N multiply with R, where S here is equal to 4,246 ringgit 46 cent minus with 4 multiply with 1,000. So the amount of interest is equal to 246 ringgit 46 cent. Let's solve this example. Example A. Find the future value of the following annuity, 1,000 every year for 3 years at 10% compounded annually. First, identify all the important values. Given R is 1,000, K is 0.1, T is 3 years, M is 1, hence I is 0.1 over 1 and N is 3. Instead of solving it manually like this example also can be solved by using formula of future value of annuity S. Now replace the value of R with 1,000, I with 0.1 over 1 and N with 3. So the amount of future value is equal to 3,310 ringgit. To find the amount of interest, use this formula, I equal to S minus N multiply R, where S is 3,310, N is 3 and R is 1,000. So the amount of interest is equal to 310 ringgit. Next subtopic is present value of ordinary annuity certain. Present value, or commonly known as discounted value of an ordinary annuity certain, is the sum of all present values of the periodic payments. The derivation of the formula of present value of ordinary annuity certain is illustrated in the following. Let periodic payment is denoted as R. Interest rate per interest period denoted as I. Term of investment is denoted as N, which means an interest period. And present value of annuity at the end of an interest period is denoted as A. As stated in the definition, present value of annuity is the sum of all present values of the periodic payments. The formula to calculate present value of annuity is as follows. A is equal to R multiply 1 minus in bracket 1 plus I power of negative N over I. The formula to calculate interest in present value of annuity is I is equal to N multiply R minus A. Now let's discuss the following example. Example B. Zikri has to pay 300 every month for 2 years to settle a loan at 12% compounded monthly. What is the original value of the loan? What is the total interest that he has to pay? As given in the question, R is equal to 300. I with the formula of K over M is equal to 0.12 over 12. And with the formula of MT is equal to 24. From the formula of present value of annuity, R multiply with 1 minus in bracket 1 plus I power of negative n over I. Substitute or replace the value of R with 300. Replace the value of I with 0.12 over 12. And replace the value of n with 24. Therefore, the original value of the loan is equal to 6,373 ringgit 2 cents. The total amount of interest can be calculated by using this formula, I equal to N multiplied with R minus A, where N is equal to 24, R is 300, and A is 6,373 ringgit 2 cents. Therefore, the total interest is equal to 826 ringgit 98 cents.